Okay, we're going to talk about the probability in cards. So some basics. When you have cards, you have 4 suits. Diamonds and hearts are red ones, and spades and clubs are the black suits. So there's 4. And within each one you have 13. So 2, 3, 4, 9, 10, Jack, Queen, and King, and an ace. So whether you count an ace at the top or the bottom. So there's 13 of those. So altogether there's 52. Okay, so let's talk about poker. When you have a poker hand, you get dealt 5 cards. So let's talk about the general number of hands you could have. So if you have 52 cards and you choose 5, that makes a large combination. There are 2,598,960,000 combinations of hands you can have in poker. Okay, so let's talk about probability of a full house. Alright, so full house is when you would have 3 of a kind and a pair. So I'm going to just draw an example. So 9 of diamonds, 9 of hearts, and 9 of spades. Okay, and then you could go something like 2 of hearts and 2 of spades. Okay, that's an example of a full house. So the probability on the 3 of a kind would be that you have 13 values you could pick from, and you're going to pick 1. So out of all values, you picked 9. Okay, so that's what that's asking. And then out of the suits, you can see that I have 3 out of the 4 suits. So that's going to look like that. And then when we talk about the pair, you now had 12 values that you could pick from, and you're going to pick 1 value, right? So you can't pick a 9, so that's why there's only 12 values. You're going to pick 1, and then out of the 4 suits, you're going to pick 2. And then that is going to be all over all possibilities. So this comes out to, when we multiply that all through, 3,744 out of, and then we have our big number here we already decided what was. So that's the probability of getting a full house. I mean, you can convert that into a decimal if you want, or whatever too. 2598. So that's the decimal, that's the probability. So 0.14%. Okay, probability of a full house. So, oh, I already did that. I wanted to do a flush. Okay, let's talk about a flush. So a flush is when you have 10, Jack, Queen, King, and Ace all in 1 suit. Okay, so would you understand that in all of the combinations of hands that you could do this in clubs, spades, hearts, and diamonds? So there's only 4 possible ways, and then out of all of them. Okay, let's do 3 of a kind. Okay, so let's talk about what 3 of a kind is. It's when you would have kind of like a full house. Let's put our 9s back in play here. 9 of hearts, 9 of diamonds, and 9 of clubs. Okay, but then that means the other 2 would be singles of something. So like, let's say a 2 of diamonds and a 5 of hearts or something. Okay, that's what a 3 of a kind would look like. Okay, so to worry about the 3 of a kind, we would have 13 values and we would choose our 1. And out of the 4 suits, we would pick 3. Then, for those, I'm going to have 12 values, and I'm going to have to pick 2 different ones. Okay, does that make sense? And this one I have 4 possibilities. I'm going to choose 1 for a suit, and this one I'm going to have 4 possible suits, and I would choose 1. And again, on the bottom, our big number. So this works out to 54,912 out of our 2 million number. Okay. What's the probability of getting, last example, 2 pairs? Okay, so I will draw you a visual of what an example could be. I guess we're really going to just work with the 9s and the 2s today. I'm going to go in 2 9s, pair of 2s, and let's go 7. We haven't used a 7 yet. So there's 2 pairs, an example. Okay, so for that, we're going to state that we have 13 values to choose, 2 different, right? So we need to choose a 9 and a 2, 2 different values. Then, within the 9s, there was 4, choose 2 for which suit. And within the 2s, right, we would have, again, 4, choose 2 of the suits. And then let's talk about the 7, the singlet. Now, there's only 11 values to choose from because we used up 2. We're going to choose 1. And then the suit, I have to choose 1 out of the 4 suits. So there's 4 possible ways I can do that. And then, again, it's going to be out of the total. So this one is a higher probability. So 123,552 out of your 2 million number.